Yes, as Heiko told, I will tell you a little bit about the Enterprise Ethereum Alliance. This is probably, as you have heard, if you are interested in Ethereum, you have heard this announcement. It had a lot of press. It had a good press because also there are a lot of really huge companies involved. You have seen the slide already, probably. I don't have to read them out, but there are really a lot of banks, but also other companies, IT companies, British Petroleum, something like this, where you can think of other use cases besides financial industry cases. So, the question is why do they form? What do they want? In fact, you can read it up. They are really open about their politics and about their decisions and discussions. They have a wiki, which you can just, it's permissionless. You can just go on it and see the mailing list and even apply for posting in the mailing lists. It's just a little difficult to find. So we will put the links on, and I think in Meetup or something. I think it's because it's the early stages, so they don't advertise it in huge ways. But yeah, it's there, and you can see presentations. You can see the vision about it. So what do they want? Why are they creating this group? And why is it necessary? I don't just repeat what's written on there. I will do it a little bit different. I give you a short agenda of what are the aspects, what is really important, and why is there an enterprise group necessary. And then I will go from a use case, a really simple one, to hopefully make sure why it's important to have such an alliance who addresses these problems. The aspects are the problems which you currently have with blockchain solutions in general, and also with the Ethereum solutions, is one thing, privacy and confidentiality, which is not the same as you can look it up. I can just explain it very shortly, but it's one refers to the person and is more important for the end users of something. So we are in this more or less public chain area here. The confidentiality is much more important for real transactions in a business space. So if we are doing a transaction and it's not so important that you are involved and I'm involved, but it's more important what data is transferred and what amount and what value. This has to be confidential. Not everybody should know about this because it can be a competitive disadvantage then. So confidentiality is really important in a blockchain in its usual implementation. You don't have this. You can see everything. That's the point in a blockchain. But yeah, this is an aspect which has to be addressed. Scalability, probably the biggest one, where you can see we have this consensus models of proof of work, which consumes a lot of energy, which is definitely not good for small chains where everybody knows each other. I will show later on why. But also scalability in terms of business functionality, where you say okay, I implemented something in a chain, let's say private chain, and I have another solution, identity solution, and I would like to mix them, have the synergies which Heiko told. This is something which is really important to see. How can this be solved? How can this be scalable in a private environment, in a public environment? Security is obviously a really interesting point, and it's not just about is the blockchain secure or something like this. This is it is, and so that's it. But it's more about what is about the edges of it. What is about user errors, or what is about problems which come from malicious attacks inside a chain where people know something and can use this knowledge. And close together with this is permissions. So permissions in a blockchain are really difficult to implement, and you will see with the usual Ethereum blockchain you can have permissions on different levels, but definitely not on these levels you need for an enterprise environment where you have roles and rights and different layers of permissions which you can have. So these are the crucial points where enterprises said okay, with the public Ethereum blockchain, we will have difficulties with respect to these aspects. So we could we just start with a really simple case. And if I understood it right, there are some developers here. So for you, it will be like, whoa, that's incredibly boring. But in fact, it's a real use case. It's a really simple use case. It's called stamping. And stamping more or less says, if you are in a banking environment, then you will know. Let's say we have 6 different banks over there, and these banks have their own data storage and everything, and we have these all-seeing eye, which is the regulatory instances, whatever, and they are looking on. They also have to see what's going on in these banks, and inside these banks, everything is just working fine. They are, let's say, they are offering a product, a financial product, and then they do publications for this, and they have to offer certain metadata, I would say, for these products, and they have to, or they want to exchange with other banks some information, and this is the problem, because then they get through from these nice processes which they have to generate all this stuff. They go down to like email and internet and Excel and whatever they have as a common infrastructure, if they are competing banks, and usually you have something like this. So as a really small example, it would be like, I want to sell a product from your bank, and you are saying like, okay, I have all these publications, and I have to make sure that you really signed them. I have to make sure that it was really you who did it and everything like this. So if we are doing this bank to bank to bank to bank, then we have a lot of reconciliation processes going on, and this is really a costly process going on. So this really costs a lot of money, in fact, people who are doing this. And yeah, it's more or less because they cannot have a common infrastructure, because they are competing banks. They don't have it. This can also be a case of a huge company with different subsidiaries. And the subsidiaries probably have some infrastructure, but still they have internal accounting, and they are not competing, but they are separated from each other. So they have the same problem. They have to exchange, I would say, some information, and this information is just exchanged in ways where you have to have reconciliation, where you have to make sure that all data pots are in sync, and this is really costly process. So what is stamping about? Stamping means that you have some digital document, whatever, I would say it now, some document, and you are doing hashing. So this is nothing really special and nothing new for some maybe, but it's nothing, not a new invention. You can go from the document to the hash, but you cannot go back. But you can always be sure, at least with current algorithms, that this document will always hash to this, and no other document will have this hash in it. So if you think about this, okay, this is taken for granted, then we are not talking about documents. We are talking about stamps, fingerprints, whatever you will call this hash. And when you use a blockchain, then you have something like attributable data, it's called. So you can say who did what when. This is a really important point. So you can say like, I created a document, I published it, you read it, I did a new version in it, and everything is written on this common infrastructure layer, which we would call a blockchain. Right now, it's done with mail, Excel, reconciliation, databases, whatever. All things are going on. So this is one point, attributable data, which is really important. The other is something which we call deterministic computation, which means with attributable data we just have the data itself. With deterministic computation we really have logic, so business logic, I would say, which runs. And this is something which only blockchains with smart contracts, in which way they support it, can use. So I think this would be quite complicated using the Bitcoin blockchain. At least it would be more complicated than with a programmable blockchain. So here you can say like, okay, I have a state of a document, or of this stamp, of this document hash, and I can really do state transitions, the computation, and I can react on something which the other bank does. So what we get here is this deterministic computation on this blockchain in a agreed upon manner. So we have to agree all who are participating that these state changes should work in exactly this way. So there probably you can see the first point why you have to have this in an environment where people get together and talk to each other and have to get together to form a solution, because this is a lot about hard work for people to agree upon one state change. But if they do, they have a lot of advantages from if you compare it with the current situation. So it would be something like this, where you can see now this is in the blockchain. The document, or here it should be better the fingerprint, is one single point of truth for everybody who's participating, with a state which is the same for everyone. The document is the same for everyone. Everyone knows who did what with this document and in which state it is. The regulator knows, so it's much easier. And if you see the red almost circle, this is the same as here. And the important thing is here, it's around these entities, these small banks with their own data stuff. This is like where their processes, this is their process context. So their processes are really quite lean usually with banks. So they're quite sophisticated. They know when I'm going to publish a document, then I will do this and that and get data from here, and everything is fine. If it leaves, if you leave the process context of one single entity, of one single of these banks, then it goes down to this mess with internet, email and stuff. And what you do here is like extend this process context to all participants. And this is also hard work. It just doesn't come from itself. But if you do it, you obviously save a lot of money. So this is something like a really small use case. We want to say, okay, we use stamping, we use hashing for this, we use state transitions and smart contracts. We don't have to, but it makes sense in this way. And so, we really could save a lot of costs. And if you want to set up something like this, I think everybody would agree to say like, okay, there are 6 banks. Why should we do it public at first? It doesn't make too much sense. If we start with the usual Ethereum client and we are going on and then this works, we have this genesis and everything, which makes sure only these 6 people are participating. And then you do proof of work. You are mining something which doesn't make any sense at all, because you are mining some currency which doesn't have value, and so it's you need proof of work to really be sure that there is someone you don't know who does the work. Here you know all entities. They are known. They are other banks. So it makes much more sense to really have an incentive in form of not some currency or something, but your banking license. If you have a banking license and you try to forge in this context, then you may lose it. So these are known entities, and you don't do something like proof of work with it. So we have like 2 crucial points: scalability or consensus model, and privacy, confidentiality. And another point is, how do you onboard new members? If you have a successful model and you have a really slim process, then how do you onboard new banks? Because they want to participate. They see like, oh, we are still doing here all this Dexel stuff and everything. Like, we want to be in part of this. How does it work? And these are all interesting points which go to private chain first, I think. We all would say like, okay, it's easier to do. Onboarding might be a little more complicated, but yeah, all other points are speak for a private chain, and also the alliance says like, yeah, people will start doing this. They will have their if you take this intranet analogy, they will have their private chains, their intranets, where they will do nice stuff, and at some point, probably they will see, okay, we cannot use these synergies and everything because we don't have the possibility, because we have a private chain here, private chain there, and we cannot interoperate with this. And then we have to invent all the stuff new, and we have to build bridges and everything like this. So what we think will be one case is this KYC, Know Your Customer and Identity solutions, who really involve the customer, and then you will have to open it to the public somehow. and you don't know how you will do it if you have a private chain. So the one strong belief of the Ethereum Alliance is, yeah, we have to support enterprises with pluggable scalability, pluggable consensus models. So you can proof of work, switch to proof of stake, switch to proof of authority, everything like this. Probably also have configurable privacy and confidentiality. But they do all this to make sure that you stay compatible to the public Ethereum as long as possible, to not have you with an intranet which just is not connectable to any other intranets which are always there. So the idea is, if they will have a reference client, which they plan to do, then it will have all this pluggable stuff, and it should be compatible to the public client. And they want to stay as close to the public client as possible, because they say, like, blockchain solutions is always about synergies, and this you can only achieve with public chains. But yeah, they also say, like, start with the private chains. It makes sense, and you can start with private chains only if you have consensus models which make sense in this private environment. You don't want to have 6 participants and one is buying 10 new nodes, and then you can do an attack or something like this, because proof of work really doesn't make sense in this context. So here are some of these attributes for private permissioned and public unpermissioned chains. And I think it makes sense to say the short-term solutions will always be a better fit with the private permissioned chains, because it's easier to start with, because it's easier to say, like, okay, if I do updates, what happens with updates? How do I do updates? How do I do versions? What is about the shared administration? All these performance issues. If I can just really easy switch to another implementation and try it out. With a public chain, this will be the thing about synergies, where you say, like, okay, how do I get new participants into this? How can I scale in terms of business functionality, in terms of use cases, so that I can say, I have this identity solution here, I have this settlement solution here, I have this here. How can I combine these? And I think this intranet analogy really fits quite well. Just with one point that one has to keep in mind, that this have the best solution for my problem is a little short for blockchain solutions, because this is really about integrating stuff and having synergy effects. I also said the one aim, really, one goal is have a pluggable consensus model, have the possibility to just say, okay, we don't need proof of work, we just need proof of authority, where you know the actors, and you can just say, okay, you and you and you are allowed to participate, and the others just can't. Then you can also say, like, then of course we don't need consensus with proof of work, it doesn't make any sense, so we could do round robin or whatever, or tendermint, like there's some resolution processes inside, but still you can really have easy solutions, and they don't cost energy. And then you could say, okay, now we go to this public chain, now we have to do proof of work, and it's just more or less like a switch, which I have to do. What is the best fit has to be really is use case dependent. So you have to know if proof of stake might be a fit, or proof of authority is just better. But it should be really easy exchangeable. I brought one solutions to show you how strong their opinion is to find generic solutions, which is the zero knowledge proofs. So definitely don't have to understand them. I couldn't explain either, but I have a really simple sample where you can see why they are important. What you have to keep in mind is, for a use case specific reason, you can have privacy and confidentiality implemented for this use case. So you have to think about it, and then you'll find a solution with some off-chain components or some whatever. It's almost possible quite easily. This solution is a more complex one, and this explanation is not technically correct, definitely, but it's for illustration purposes only. It's just to show that this exists already, and you all who are using the blockchain, whatever blockchain, really are trusting this mechanism. The mechanism is more or less, I have a claim. The claim here is I have a private key for some Ethereum address, and I can show it. And I don't show it if I give you the private key, because then it wouldn't make any sense. Then the whole system fails. The private key has to stay off-chain with me. But I can sign a message, I can give you the message and a signed message, and you can derive the public key, and you can derive your address, and say like, okay, it's true. If I trust mathematics or algorithms or whatever, and currently it works exactly this way, then I can be sure that this guy has this private key to this address, even if I don't know it. And this zero knowledge proofs don't make so much sense in this case, or they make much sense, but for our use case not. But if you think of something like we are doing a confidential transaction, and I give you something, then people will know, okay, he gives something to him, but it's hashed. You don't see what amount of value it is. It's also not really important. What's important is that we agree that I cannot sell more to you than I have, and that the balance of mine should be less than before, and something like this. And if you have a proof which says like, okay, after this transaction it's sure that he still has some tokens, and you have more and exactly the difference, then you don't have to know what the exact value is. So this is more a generic, quite complicated solution, but they are trying to push it because they say like, if it works, and it works definitely. It's just like a thing about how good does it work, how easy can you use it. There is some baby Zoe zero knowledge on Ethereum, which showed that it works. But it's just to show, they are really honest about this stuff. We want to give generic solutions to be able to switch from private to public. Security and permissions is what I said. Like, you have like in a proof of authority, you have some identifiers for validator nodes, and only they are allowed to participate. So it's a completely different thing from unpermissioned blockchains, where you do your proof of work and everything like this. Here you say like, okay, you are allowed, the others are not. This is something where you can prevent someone from getting into the system, but has nothing to do with permissions or something like this. Permissions you can do contract based. You can do something like this. If you know Ethereum, you will know this. Only the creator of this contract is allowed to do certain stuff. So this is the if sender is not owner, then throw. So this is the contract-based permissions, and if you know the enterprise environment, you know that okay, that's nothing. We have to have roles, users, user roles, rights, concepts, and everything like this. So it gets much more complicated if you have an enterprise grade or enterprise granularity permission system. So this is something you can implement for yourself all the time, or the Alliance finds templates, finds best practices, finds something like this in their working groups to give you advice how to implement it. This is what they care about. So all in all, really in just these points, scalability is really the thing about the pluggable consensus. It's really important that this works, and there are also in these clients right now, I think it is even possible right now, but they still have to modularize it a little bit more. Sharding, parallelization, I didn't speak about. State channels you will hear a lot about today. It's also about scalability in effect. Privacy and confidentiality, ring signatures, and the zero knowledge proofs address all these facts. This is all research in the Alliance. Individual solutions, templates for industries, for special industries, like certain industries like medical, or for banking, where you have probably a little bit different understanding of privacy and confidentiality, has to be worked out. This is what they do in working groups. And then security and permissions, even on an application or user security level, which is quite interesting. If you think of, if you are working in a huge enterprise, you know that they have they say like, okay, we use these algorithms for security related issues and no more, because these are whatever, like went through thousands of documents, and they are fixed, and so you cannot just use this Lampert whatever quantum proof algorithm of Ethereum. So you have to have the possibility to switch this also per user, per application. This is also something they are working on. And probably one of the most important facts, something like to have a governance for updating, versioning, shared administration, because what is it when we are 6 companies, and how do we do our contracts? Who administers it? So each person for itself, of course, but still we have to stay interoperable, so we have to have some consensus about when do we upgrade, what do we upgrade, how does it work. So in these member interest groups, they are addressing exactly this stuff. I put one BrainBot slide in here because just for you to know that it's not only in San Francisco, in New York, and wherever these companies are, it's also in Mainz, that there is a company addressing all this stuff. Also as a, I think it's true as a member in the technical steering group, as a member definitely of the EA, I think also as a member of the technical steering group, and for active development of the reference enterprise client for Python. They are doing all these projects, which you will see later on. Okay, yeah, we have some resources here. These will go on as links on the Meetup space then. That's it. I don't know if it makes sense to make a question and answers now, or do just a break and then you can come here, ask me, or go outside.
I would like to have a 5-minute question and answer to the speakers. Just a real quick 5 minutes. If anyone has some questions, and afterwards we will have a little break. Drinks and food is free. Sponsored by PwC, sorry. Common mistake, I guess. And after the break, we will hear Andreas from Deutsche Börse. Any questions to the speakers? Yes, please.
Yeah, so I have a question regarding the outlook for the transition from private Ethereum chains on the public chain. Yeah? Because once you switch to proof of stake, and we all know that the distribution of wealth in Ethereum terms, in Ether terms measured, is extremely unequal. Yeah? So you have a lot of market power of very few players in the market. So do you actually believe that banks will put their fate into the hands of a few people that are validating the transactions in the proof of stake framework? I think that's, rather unrealistic.
I would also give this question to Heiko, but I would say it depends on how you find solutions to this shared admin stuff and the update stuff and all this. Like if the other people can just destroy anything, then it doesn't make sense. But if you find a framework in which you can really find solutions for this shared admin, for the versioning, for something like this, and even have something like emergency measures or something, then it could be. But it's definitely it's a problem. Yeah, if you have to rely on something like this. This is one argument for private or consortia chains. Then, yeah, but I don't know.
Heiko? So with proof of stake systems, depending on how you design them, you can actually exactly calculate how much value is currently secured when consensus protocol rounds run. After every block, more history is signed by more participants who have something at stake. So if they at some point decide to not go for that history, but for a different one, they will lose their stake. So with every block that passes on, the security that you have gets higher. And you can actually measure that. You can exactly calculate how, in monetary terms, secure that history on the blockchains. That's not answering the question.
Okay, you can do a follow-up question in the break, maybe. Any other general questions to the speakers? I guess it's break time.
Yeah.